In this video, we will install Elasticsearch and Kibana on a single node k3s cluster. Elastic Cloud on Kubernetes, or ECK, will manage the deployment. ECK automatically creates TLS certificates, credentials, and the required Kubernetes resources. This setup is intended for a lab or development environment. For production, you should separately design a multi-node architecture, backups, persistent storage, and trusted TLS certificates. I am using Ubuntu 24.04 as the example server. You need sudo privileges and internet access. Although k3s is lightweight, Elasticsearch consumes significant memory. For a comfortable lab, I recommend 4 virtual CPUs, 8 GB of RAM, and at least 40 GB of disk. Elastic documentation notes that the node needs at least 2 GB of free memory for the Elasticsearch pod to start. Use free, df, and uname to verify memory, disk, and architecture. Run the official k3s installation script. It installs k3s as a system service, configures automatic restart, and adds tools including kubottle. Check the service status, then confirm that the node reports ready. You can use the bundled client directly as sudo k3s kubottle. If you plan to use standard kubectl or Helm, export the kubeconfig path shown on screen. This is the default location created by k3s. Now install ECK version 3.5.0. The first command creates the custom resource definitions that teach Kubernetes about elastic resources such as Elasticsearch and Kibana. The second command deploys the operator in the Elastic system namespace. The rollout status command waits until the operator is ready. If you see an error, inspect the pods and operator logs in Elastic system. This step requires cluster-wide administrative permissions. Now, define both resources in one YAML file. The Elasticsearch resource uses Elastic version 9.5.1, a single node, and an mmap setting suitable for a development environment. This setting simplifies the quick start, but can affect production performance. The Kibana resource uses the same version and connects to the quick start cluster through Elasticsearch ref. ECK automatically manages connection details and certificates. Save the file as elasticstack.yaml. Apply the manifest. You can monitor Elasticsearch and Kibana together. The first image pulls may take several minutes. The cluster is operational when Elasticsearch reports green health and a ready phase. Kibana should become available. If a pod remains pending, first check available resources and the persistent volume claim. If you see crash loop, back off. Pod, describe output, and logs are the best starting points. ECK creates the password for the Elastic user in a Kubernetes secret. Retrieve it with the command on screen and store it securely. Forward the Kibana service to your local machine, then open HTTPS localhost 5601 in a browser. Because the default certificate is self-signed, your browser may show a warning in this lab environment. Sign in with the Elastic user and the retrieved password. Port forwarding is only for local testing. In production, design an ingress or load balancer with trusted TLS. Now test the Elasticsearch API. Forward port 9200 from the service. Then export the public certificate created by ECK to a local file. Use that certificate and the Elastic password in the curl request. The commonly seen insecure K option disables TLS verification, so we do not use it here. If localhost does not match the certificate names, use the resolve method documented by Elastic. A successful response shows the cluster, name, version, and build information. The installation is complete. Before going to production, configure at least 3 Elasticsearch nodes: capacity planned persistent storage, a snapshot repository, resource requests and limits, pod anti-affinity, trusted TLS, monitoring, and alerting. A single node k3s cluster and the default 1 GB volume are only a starting point. When changing versions, check compatibility between ECK, Elasticsearch, Kibana, and Kubernetes. Use the official documentation links in the description to verify the latest commands.